Welcome back to the channel. Today I'm going to show you a clever setup for secure private browsing from anywhere in the world. Perfect for when you are on a public Wi-Fi or traveling. We are using Cloudflare WARP with MASQUE protocol, which has a unique advantage. It looks just like a regular HTTP traffic. This means it's much harder for firewalls to detect and block, unlike traditional VPNs. By combining MASQUE with SOCKS5 proxy and custom exit node, you'll get a secure, reliable connection that keeps your real IP address hidden, protects against eavesdropping, and bypasses geographical restrictions with ease. My name is Philip. Let's jump right into it. When I'm traveling or staying at a hotel, I connect back to my home using a WireGuard VPN. At home, I have a VPN exit node, which is the point where VPN traffic exits onto the internet. This setup means that my laptop or mobile phone establishes an encrypted tunnel to my home network, and my home router then sends my traffic to the internet. To the target website, it appears as if the connection is coming from my home IP, not from hotel or unfamiliar network abroad. This setup essentially masks my actual location. So, why go through this trouble? Firstly, if you are on a public Wi-Fi or any network you don't control, there's no guarantee that someone isn't snooping on your traffic, recording it, or using a rogue DNS server that could redirect you to fake websites. Even with DNS over HTTPS and TLS encryption, it's still possible for someone monitoring the router to see a list of your established connections, gaining insights into what you are doing online. Another advantage is access control. Some sites are accessible only from specific locations, and many countries restrict access to certain content, enforcing censorship. A VPN exit node can help you bypass these restrictions, giving you more freedom to browse. Using a VPN exit node enhances privacy, anonymity, and security. However, it's not a perfect solution. It won't protect you against every form of tracking, especially things like cookies, and it can slow your connection slightly due to encryption overhead and added latency. I recommend using WireGuard as your VPN tunnel protocol. It's reliable, modern, and fast. But there are a couple of potential issues to consider. First, a WireGuard server generally needs a public static IP. This means you typically need access to your router, which isn't always possible. If you are using an ISP-provided router, you may not have direct access, and even if you do, your IP address may be dynamic. Workarounds like dynamic DNS or mesh VPNs can help, but they are often a bit cumbersome. This is where Cloudflare WARP service becomes useful. By installing a WARP connector on both your PC and your VPN exit node, you can establish a WireGuard tunnel to the nearest Cloudflare data center, effectively connecting your devices through Cloudflare infrastructure even if you lack a static IP. The second issue is that some firewalls block UDP traffic, which WireGuard relies on. An easy workaround is to run your WireGuard server on UDP port 443, as this is the same port used by QUIC. QUIC, developed by Google, is a transport protocol that replaces traditional TCP with TLS and is the foundation for HTTP version 3. Using UDP port 443 can bypass many firewalls that filter based solely on port and protocol. However, some advanced firewalls with deep packet inspection can detect the WireGuard protocol. So, what's the solution then? Cloudflare WARP client includes a new protocol called MASQUE, which extends HTTP version 3 capabilities to tunnel both TCP and UDP traffic. Since it leverages HTTP version 3 and QUIC, MASQUE can often bypass firewalls that would otherwise detect and block VPN traffic. Though MASQUE is still in beta, you can configure your WARP client to use it, allowing for even greater firewall bypass capabilities. Let's dive into the solution design. Our setup includes a Windows PC at one location, acting as the client, and an Ubuntu server at a different location, acting as a VPN exit node. Both devices are running Cloudflare WARP clients, which establish secure tunnels to Cloudflare network. The WARP connector uses the MASQUE protocol, leveraging HTTP version 3 and QUIC, which makes it harder to detect, as it looks like regular HTTP traffic compared to WireGuard. With this setup, we have a secure connection between the two devices. In a typical VPN setup, you might configure NAT on the exit node and set the client's default gateway to route all the traffic except VPN peer traffic through the exit node. However, with Cloudflare WARP, all internet traffic by default goes through Cloudflare network. Technically, we could update Cloudflare routing to push all traffic via the exit node, but that would require adding around 100 custom routes. Possible but tedious. A simpler solution is to install a proxy server on the exit node and then configure the client to use the proxy node. Two popular options are Dante SOCKS5 server and Shadow SOCKS. Since our tunnel is already encrypted, Dante SOCKS5 is the easier choice here. Essentially, we'll configure the client to use the SOCKS5 server hosted on the exit node. The WARP connector then tunnels this traffic through the Cloudflare network using MASQUE protocol, which routes it to the exit node, where the SOCKS5 server forwards it to the internet. Let's get started. The first step is registering with Cloudflare Zero Trust. The process is straightforward, but if you need guidance, check out my other video where I go over the registration steps and additional WARP settings in detail. Once you're registered, let's set up the configuration. In the Cloudflare console, navigate to Zero Trust, Settings, WARP Client. Here we need to adjust a few parameters. First, scroll down and enable Override Local Interface IP. This setting will assign a unique IP address from the subset of CGNAT range, that's 100.96/12, to each node that joins our network. Next, we'll go to the device settings and edit the default profile. We'll start by changing the tunneling protocol to MASQUE. Then, in service mode, we'll select tunnel-only mode since we won't be using DNS filtering. Next, we'll save our profile changes. Now, we'll edit the profile again. I will scroll down to Split Tunnel Configuration. Here we'll define which traffic should go through the tunnel and which should be excluded. Since we want only the 100.96/12 network to be routed through the tunnel, I will change the mode to Include and add the 100.96/12 network. Finally, let's go to Settings, Network, and Enable Proxy, so our traffic is forwarded to Cloudflare Gateway for inspection. Be sure to select all protocols, TCP, UDP, and ICMP, and check Allow Warp to Warp Connection to enable communication between our two nodes. Now let's set up the exit node. First, we need to install the WARP client software on our server. We'll start by going to Settings, Resources, Linux, in the Cloudflare console, where we'll find WARP installation options for various operating systems. Let's begin by downloading the GPG key. Next, we'll add the Cloudflare repository. Finally, let's update the packages list and install the WARP client. Now let's connect our exit node to the Cloudflare network. Let's navigate to Networks, Tunnels, and select Add a Tunnel. I will choose the WARP connector as the tunnel type and name this tunnel Exit Node. Then let's click Create Tunnel. Cloudflare provides installation instructions, but since we already installed the software, we'll simply copy the connection command shown at the bottom and run it on our server. Once connected, we can confirm the connection to Cloudflare by running the status command. Everything looks good. To verify tunnel settings and check its stats, we can use the settings command. Okay, connection works and the tunneling protocol is MASQUE. The tunnel to Cloudflare network is now up and running. Finally, let me click Next and then return to tunnels to complete the setup. Now let's set up the WARP connector on our Windows client. First, I will go to Settings, WARP Client, Manage Device Enrollment Permissions in the Cloudflare console. Here you can define who is allowed to connect devices to Zero Trust Network. I will click Add a Rule, name it Client1, and enter my email address. This email address will be used to authorize the device for network access. Finally, let's click Save to apply the rule. Next, let's install WARP software on our Windows client. I will go to Settings, Resources, and download Cloudflare WARP for Windows. Let's run the installer. Wait for it to finish, and then click on the gear icon, then Preferences. In the Account section, let's select Login with Cloudflare Zero Trust. It will prompt for the team name. This is the same name you specified during registration. To find it, go to Settings, Custom Pages in the Cloudflare console, and copy the team name. Let's enter it here and click OK. Now the installer will ask for an email address. We'll enter the same email address that we've set up in the enrollment policies, then click Send me a code. Let's check the email for the code. Now enter it here and click Sign in. Finally, let's connect to the network by pressing the large button. We are now connected to the Warsaw data center. If we go to My Team in the Cloudflare console, we'll see both devices, the Windows desktop client and the Ubuntu exit node. Let's test the connection between our client device and the proxy over the Cloudflare network. First, I will click on the proxy device in the Cloudflare console and copy its IP address. Next, I will open the Windows command prompt and ping the proxy to check the connectivity. It works. To see the traffic path, let's run the trace. We can see that the traffic flows through the Cloudflare network, confirming our setup is working as expected. With connection established between our client and exit node, it's time to set up Dante SOCKS5 server on the Ubuntu machine. Let's start by installing the Dante SOCKS5 server. Next, I will copy a minimal configuration file to the appropriate location. Then we'll restart the SOCKS5 service. To confirm the service is running, we'll check its status. Everything looks good. Here's a quick breakdown of the configuration. The first line specifies the serious errors should be logged to syslog. General log output is set to dev null, discarding non-critical logs. The interface and port where the server listens for connections are defined. This is where the clients will connect to. The external interface is set up for the proxy outbound connection to the internet. Authentication is disabled for clients and SOCKS rules. User accounts are defined for Dante's elevated privileges, regular privileges, and TCP wrappers. In the client rules, only the 100.96/12 network is allowed to use the proxy. Finally, the configuration permits the SOCKS server to relay traffic from any source to any destination. With this setup, our SOCKS5 server is ready to go. Alright, let's test the setup by checking our public IP address. Then, I will open my browser settings, navigate to the proxy settings, and set the IP of SOCKS5 proxy to our exit node's address where Dante is running. I will set the port to 1080. Now, if I check my public IP address again, it displays the public IP of the exit node, confirming that my traffic is being routed through the SOCKS5 proxy. This setup now allows me to securely browse the internet. If we capture the traffic to the 162.159.197/24 range, which is dedicated to the MASQUE protocol, we'll see it appears as regular quick traffic. This confirms that our setup is securely tunneled through Cloudflare network without detection. And that's it. You've got your robust private browsing setup using Cloudflare WARP and MASQUE protocol with a SOCKS5 proxy, all running through your exit node. This configuration not only keeps your connection secure, but also ensures that your internet access is truly private. Don't forget to like, subscribe, and drop any questions in the comments below. I'd love to hear how this setup is working for you, or if you have ideas for future topics. Thanks for watching, and I'll see you in the next one.